in this lesson, we're going to be taking a look all at inverses. Now, as we do this, there's going to be a decent amount of notes, a lot of little detaily things to get along the way. So do make sure you take advantage of the fact that you can pause the video and write down the information as we go so that you don't just miss out on something. You can pause and rewind. Use that to your advantage. All right, so in this case, we have a table for f of x. And we want to make a table for the inverse of f of x, which is written as that. Now, that looks like f to the power of -1 of x. And that's basically how it actually gets typed and written. But it doesn't mean to the power of -1. That power of -1 actually means inverse. So we actually read that then as the inverse of f of x. Now, the cool thing about an inverse is that it really is as simple as swapping the x and y values. That's really all there is to it. So for instance, in order to make my table for the inverse of f of x, I'm going to take the points in the original and I'm just going to swap the x and the y. So instead of -3, 9, it becomes 9, -3. And that's all there is to finding the inverse. So like for the next one then, instead of 0, 8, it's going to be 8, 0. Okay, with that in mind, go ahead and fill in the rest of the table. And then just so that we can see a picture of what's going on here, we're going to go ahead and plot the points for this on a graphing grid so we can see what this would look like. So I'm going to go ahead and use different colors or symbols here. Use whatever makes most sense for you. I'm going to use a blue dot for the original f of x here, and I'm going to use a red x for the inverse function. So the blue dots, f of x first. If I plot each of those points, that's where they happen to end up. No, we aren't worried about what equation this represents. All we're doing is plotting the points so we can see a picture about what happens when we look at the inverse. And so then I plot the points from the inverse. And just to kind of make that a little bit easier to kind of visualize because they're overlapping a little bit, I'll go ahead and draw the curves in through those. Now, of course, these are just rough curves because I don't know what's going on in between those points. I don't know if there's even points between those points. But I just want to have a visual in order to be able to connect those to see what's going on. Now, you'll notice between that blue graph and that red graph, they actually have the same shape to them. The only difference is that their orientation seems to have changed. In fact, if we want to get very technical about it and dig deep onto these, as we will, you'll find that if I take my original graph and reflect it across that line, I get the red graph. So that's actually what's going on. Now, because it's a reflection like that, yes, it will be the same shape. And it should always be the same shape. The inverse will be the same shape as the original every single time. The only difference is that it's just been flipped over that particular line that you see drawn there. Now this is just kind of get you an initial picture of what the inverse does and what it might look like, but we're going to be digging into a lot of details as we go forward. Now the big idea behind inverse really is this concept of swapping the x and y values. So a little bit of notes here. Notice this idea of swapping x and y comes up in every single one of them. Please do, though, add this into your notes for each of these. And, of course, pause the video long enough for you to be able to write them down, and then you can press play again so that we can continue working through the examples. All right, so then, now we're going to practice finding an inverse. Now, notice this time I'm starting with an equation. So notice in your notes it says that in order to be able to find the inverse of an equation, we first swap x and y, and then we solve for y. Now, one thing that sometimes throws people off here is they look at it and say, yeah, but there's no y. It's f of x. Well, if that's the case, make your life a little bit easier. Write the f of x then as y. So just write it as y equals x² + 1. Okay, now it's x and y. So swap x and y. So that would mean x equals y squared plus 1. Then, having done that, we will then go ahead and solve for y. So I'm going to subtract 1 from both sides. So that gives me x minus 1 equals y squared. And I still need to solve for y. I got that squared there that I need to get rid of. In order to get rid of that squared, we're going to take the square root of both sides. Now, when we take the square root of both sides of an equation like this, what do we need to remember to include? Hopefully, you're remembering that plus or minus. Notice the plus or minus goes on the side where the squared wasn't. And so, in this case then, we end up with plus or minus square root of x minus 1 equaling y. Now, in the original, it was not y equals. It was f of x equals. And so in that sort of a case, then you'll notice then we just will then take our y and rewrite it as the inverse of f of x. And so then our final answer will be the inverse of f of x equals plus or minus, yes, you need the plus or minus, x minus 1. That is our inverse equation. All right, now that I have my inverse equation found, I again want to take a look at the graphs and see what's going on with those. So let's go ahead and now graph the original and then take a look at the graph of the inverse of this function that we know here. So I'm going to be graphing f of x equals x squared plus 1. Okay, well, that I know is a quadratic shifted up 1. So I can go ahead and graph that, and now I need to graph the inverse function. The inverse of f of x equals plus or minus square root of x minus 1. A lot of people get wondering, what does the plus or minus do to the graph? Well, basically, just like in the quadratic formula, for instance, that plus or minus means do it once as plus and do it once as minus. Same thing here. So we're going to graph just a plain old positive square root of x minus 1. The minus 1 being inside the square root moves it right 1. So the positive square root would look like that. But I also am going to graph the negative square root of x minus 1. The negative out front, remember, flips the graph upside down, and only upside down. It's still going to be pointing to the right. So I am still going to start right 1, but I go down instead. Notice by doing that, that also shows why we need the plus or minus, because remember, the inverse has to be the same shape. And in order for that inverse to have the same shape, it does have to include both sides of the original graph, hence the plus or minus. Now, a little more detail here just to look at the graphs and how they're related to each other. Here I've drawn in green dotted lines between the points that are connected to each other, the ones where we would have flipped the x and y's. They are the corresponding points. Notice all of those lines are parallel. If I take a look at what all those lines are going across, they're all going across this same line here. And you'll notice that each of those points then is a reflection across that line. And because it is a reflection across that line, we can also then see that the original and the inverse will always be reflected across that line, the equation of which is y equals x. And so one thing you'll hear said about an inverse is that the inverse is always reflected across the line y equals x. Last question coming out of this problem, a little detail-y thing. Are both of these functions? Well, the original was, that's why we called it f of x, is the inverse a function? Well, remember the way that we can test to see if something is a function is by using the vertical line test. If it is a function, we can never hit more than one point of the graph at a time with a vertical line. Notice our original passes that test, but the inverse does not. And so, no, they are not both functions, which also shows us an interesting little detail here. F of x is used to represent a function, and only a function. However, when we're talking inverses, the inverse of f of x, that notation, that function notation may be used even if the inverse is not a function. All that's telling us is that the original was a function, but not that the inverse was a function. Now that's just one of many details about these inverses. These are a lot of other little details here. This is kind of a summary of a lot of things that I've kind of touched on here, maybe even with a few extra things in there. Go ahead and just take a moment, pause the video, and write this down into your notes. All right, now with that down, one thing I do want to point out, I'm mentioning it here, but it's not going to be a big point of emphasis, although it often would be in this class, but because of time, we aren't making a big emphasis on it. This mention of the domains and ranges being swapped. Domain is just a description of the x values. Range is just a description about what y values are included. So because the x and y values are swapped, their domains and ranges are also swapped. Now that has some interesting implications that we're not going to dig into so much this year, but it really is an interesting piece that ends up coming up in some other ways. All right, last thing we're going to do is go through two last problems of finding inverse equations. And for both of these, I'd like you to write down the original question, do the problem yourself first, and then after having paused the video, resume the video to see the work that was done for it. So go ahead and do that now. All right, so to find my inverse, step one is to swap the x and y. So this is going to become x equals negative 3y plus 6. I now need to solve the equation for y. So in this case, that would mean subtracting 6 from both sides, and then dividing both sides by negative 3. And so having done that, that will leave me with x minus 6 over negative 3 equals y. All right, yeah, that is our inverse. Now, if you wanted to try to mess with the formatting a little bit to make it look like something you're more used to, you could. We could actually put this into like a slope-intercept form by dividing both terms individually by the negative 3. That would give us negative x over 3 plus 2. Or negative 1/3 x plus 2, if you prefer writing it that way as well. But either way you write it, it is our inverse. All right, last problem. And once again, do this one on your own first, then watch the answer worked out. All right, step one, swap the x and y. So we're going to have x equals y squared minus 9. I'm solving for y. Add 9 to both sides. Now I need to take the square root of both sides. When I take the square root of both sides of an equation, what do I need to remember to include? Plus or minus. And so that is now our inverse equation. That's it. That's done. I got y equals, so I'm done. Now, you might be wondering, could we now change that into like square root of x plus 3? No, you can't. We cannot take the square root of each term individually. Just like if I were squaring that side, I couldn't just square each term. I'd have to like multiply the binomial by itself, that sort of thing. Square roots are the same thing. You have to take the square root of the entire binomial as one big chunk, not individual terms. And so, no, you cannot just take the square root of the 9 there. This is as good as that one gets.